Good afternoon. I'm going to tell you about these strange abbreviations, peculiar abbreviations. Actually, my presentation is about our experience and what happened to us when we were making out how to use RDMA. Maybe it will help some of you avoid our mistakes and simplify your life. So, how did it begin? We are making a storage system, a hybrid storage system type, unified. It can communicate to different protocol, block, file, object, and so on. And inside it, there is a PCI fabric which connects all the system components, and it looks like this. So we have computing controllers, which are called storage controllers. We have fabric controllers with the periphery, and all this is connected to PCS. And the problem for us was to connect all these controllers, storage controllers, so that they can communicate quickly with each other. And what's interesting, we are using open power and SUSE Linux Enterprise with quite an obsolete kernel, 4.4 LTS, because we are working with LTS user and so on. So that's how we began. So as I said, we were looking for a connecting mechanism between storage controllers, which would allow us to have fast cache and synchronization system, so that this system is not a bottleneck, but a good platform for us to have an efficient system. So all these components live in the kernel, so all these mechanisms should be accessible from the kernel without going out to the user space. So we had a couple of options. We could take PCI NTB or something on TCP, but we left it for later if we don't succeed, and RDMA was an option. So we did not begin with RDMA. We decided to start with RTB. NTB. We have a good chip which is used to ensure communication between control and fabric. There are 16 lines of PLX Express, and it is connectable with NTB, but our switch is not very much compatible. So the working speed was too low for NTB. It was not optimal. So we decided to look into RDMA. TCP we left for the future. So what is RDMA? This is a mechanism of direct remote access to memory, which can allow to read the memory without connecting to host. So it's quite efficient. There are a couple of variants of this technology. You can see them on the slide, and here special hardware is required to support all these features. We decided to take up RDMA over converged Ethernet because we had equipment to test it upon. So it can allow us to encapsulate everything in Ethernet or UDP. So by default, Ethernet can lose frames. So Ethernet should be really reliable for this feature. So there are certain standards which allow us to have a reliable Ethernet using cables. This makes it impossible to lose frames. That's how it looks like in a cable. We have Ethernet frame, and there are some headers here, and InfiniBand frame is moving along the cable, and in the second version, header is replaced by TBH. So this is an IP traffic which is flying in the Ethernet. And in order to test all this, we had two servers on power, two Mellanox connectors, Connect X2, and we have a very good link which allows us to bring everything together. So we tested it with a client. Everything proved to be operational. Now we had to program all this. So we had to write our drivers, and there are two parts of API which allow us to use it. One part is responsible for establishing communication, the other one for data processing. So the first is communication manager, the other one is verbs. In order to establish connection, we can use our client server. We can perform a number of options which are depicted here on this slide. They are quite simple, but you have to call for them in a proper order, and there is a machine which collects them together. So we are creating production domain, and we create queues, pairs of queues. We start polling for events, and we are ready to go. So we have a lot of abbreviations. They look peculiar, but you can get used to them. So what is InfiniBand verbs? So this is a specification which describes what kind of data you can use, how to write something in the memory, how to make it invalid. So we create work request, we state its type, we assign memory buffers, we send it to pair and wait until it is completed. So our request is made. In order to read a foreign memory, we need to be able to register it. So the operator will be informed that this memory can be read without a processor. So the kernel will pin pages, will map them in DMA, and will provide a remote key which will allow another host to connect, to communicate with this memory. So you can register memory differently. You can find memory registration, fast memory registration, memory window, and fast memory registration mode. All these are working differently, but they're working in the same direction. So we selected the last option. Actually, that's all with me. So Carpin was the base project. So here you can find the last version with the full description, how to establish connection, how to send data, how to read data, invalid memory regions, and so on. So this is a kernel module which can do all this. So this is a good example of API usage in the API kernel. So it works with 4.4, which is good. So that was about utilization. Actually, all I said is quite obvious. You can find all this information in the internet. So, what happened next? Well, we have RDMA. It's working. We have some API which we're able to use. Now we need to develop something for it and test it automatically. So, we need a kind of mechanism to launch our RDMA applications on laptops, in virtual machines, and preferably without any specialized hardware because it's not very useful. So in case of virtual machines, we can use PCI virtualization. We can virtualize one adapter for many adapters. It's working, but it's not very useful because you need to manage these adapters. You have to assign it in virtual machine, so it's not very handy. We were lucky to have Mellanox. They thought about it and created a driver which can implement this at the level of software. So they are working with any Ethernet card, even with virtual interfaces, virtual driver and so on. Anything is compatible. It's even compatible with the protocol with physical adapters. So you can use it with hardware. And kernel is 4.8. 1 year ago it was merged, and it has been working since then. But our kernel is 4.4 still. It's already available in SP3. It was launched 1 month ago, but we're not using it yet. So we decided to put it into SP2. We took something similar to FPI 4.4. We took sources from 4.10. We put it into 4.4, compiled, and now it's working. So we launched the same test utilities, and it started to work. Ping, which worked with hardware cards, is not working in the kernel. Actually, that's what we need. We tried to map DMA memory, but we failed. We found out that when programming DMA, we do not need to map memory directly from DMA, but there are certain wrappers which do the same, but inside they allow to describe a special behavior for drivers. So in case of software driver, we do not need RDMA because we have everything we need in the software driver. So we can use something like DMA, but without it. So there are certain marks which can do all this. So everything was operational. However, we could not map more than one page. So we can separate one page, half a page, but two pages, one after the other, cannot be mapped. However, if we map this page and get an address and put it into page single, it will work and you will be able to read it and to write in it. So it's quite strange. So we looked into it and found this wonderful code pre-mapping of a page. Strangely, it says that we cannot map more than one page. Where did it come from? So we did not understand, but that's what we have. Our study showed that in following kernels, this will not be present. There will be some common framework for virtual DMA mappings, and So we removed this, and life got easier because it worked. It started to work, so everything was fine until we realized that we could not record more than 1 kilobyte of data. However, we could read, we could map a big page, and we could record it 1 kilobyte after the other. And a passive participant announced a mistake, and the others left and did not return instead of giving back a mistake. So that's how it looked like. We record 1 kilobyte to packaging right first and last, and request is trying to record, but silence is the answer. Practice showed that it's connected with MTU. If we get MTU, we can record about 4 kilobytes, but not more. So we started to look for the reasons, and that's the code we acquired. This is interesting here. If we get a request for recording more than MTU can allow us, we can answer that we can have only the package size for MTU and not longer. We could respond that something failed, and that was the end. So we found a mistake, we corrected it, and in 4.12 it's already corrected. There was a big description of the work done, and 2 lines were removed. After that, it was much easier for everybody. After that, we found a nice prefix which allowed us to find more corrections. That's how it works after corrections. So in InfiniBand RXE prefix, we started to look for other corrections. This is one of 5 pages we could import, and we found a problem with resource drain, some crash. So we selected something from here, backported it, and it worked. So everything was fine, except for the problem with recording. So if there is a mistake, it is not sent back to the one who requested. So it gets stuck there, and it can happen for several types of mistakes, of errors. Well, it looks this way. If you try to read what's already absent, there are different aid requests, and in this condition, the system may stay for quite a long time. Right away, we look in the source, and we see the following. For certain types of errors, the driver is sending the acknowledge of something that went wrong, but for certain types of errors, it does nothing. That's it. Raw state, and that's it. What's the difference between class C and class B? We couldn't clarify till nowadays. But If we add the sending of acknowledge on all the types of errors, it begins to work, and it works okay. Negative and acknowledge assists us. And it looks roughly this way. We've sent the query, acknowledge is coming, and syndrome tells what went wrong. Everything is okay. We fixed it. Of interest is that it's still absent in the upstream. There are two options. Either we misunderstand something, or nobody cares. Perhaps both. After it, this RXE drivers did work. The only problem left is that it still requires reliable Ethernet. And it doesn't work in VirtualBox, for example. Or it works, but conditionally. The VirtualBox that we've used under Mac for the development, it begins to lose if you write to it a lot and do not send anything in exchange. If we try to record 4 MB via RDMA, after 2 MB, it stops to accept packages, stops sending packages, and that's the end of it. Perhaps it's because the transmission flow control is absent over there, and yet we don't know what to do with it. The good news is that we have given open switch. All these Linux technologies do help us. They assist us. And perhaps some other kinds will work with it as well. Well, that's now the summary. RXE is a good option for testing, developing, automatic testing. It works. A convenient thing is that it doesn't require any hardware, and in the new kernels, it doesn't have to be fixed. Everything that could be fixed is already fixed. If you really want, you can import it into the old kernels. It again works, but one has to be attentive about the patches in the upstream. Lots of useful things over there, but all of a sudden, there may be unexpected things. The good news is that it works on power. It really helped us. And if you have wrong Ethernet, it's senseless. It won't work. Again, if you use the virtual switches, it works. If it goes onto this physical switch, then you have to do a lot of settings. That's probably it with me, and I'll be happy to take your questions, if any. Sorry, the question isn't coming into the mic yet, so the interpreter can't hear and translate it. Thank you so much for the presentation. As far as I know, the absolutely reliable Ethernets haven't been invented yet. Yes, some are more reliable, some are less reliable. Some lose packages once a year, some do it every minute. However, Ethernet is not TCP. It will lose packages. So if you say the Ethernet has to be absolutely reliable for its work, it means it will never work. I mean, I compared with traditional Ethernet when we had collision domain, when we were sending these preambles to detect collisions. I remember the switches with buffers that were also overloaded, and packages were rejected because there was no space for them. So different tools were invented to overcome this problem. So on top of that, the hybrid channel works. And there's this SUSE protocol that doesn't like when commands are lost. Of course, things are lost, and nobody's insured against it. Of course, somebody may unplug the wire from the server and then plug it in quickly. Yes, the errors will take place. That's normal, and we'll have to work with those errors. That's our work. And probably there are different
ways of correcting those errors, but still it's less painstaking than the usual Ethernet that provides errors much more frequently. So it was normal for the previous internet to lose packages. So we need just a more reliable, not the absolutely, but a more reliable Ethernet. That's it. Thank you very much for your presentation. And tell us, please, why didn't you choose for interconnect in that storage of yours the native InfiniBand right away? Well, we needed the PCI Express because it's used for switching of devices to storage controllers. If we get back to the very beginning, just remember where we had our image. The very, very beginning of my presentation, please. Yeah. Here, see? There's a box called Fabric Controller, and in it, the drive enclosure is plugged in. The thing is that we have the host adapter that realizes the SCSI, and later, via the PCI, it's unmapped within the storage controller. So we already have the PCI interface that enables us to work with lower devices with the help of PCI bus and without any additional code. If we already have the PCI Express that works, we can actually push into it anything we like. It's because we have the PCI Express that we are already working with. What about storage controllers? Two of them. Is it an expander or is it a server? It's a server which doesn't store data. It's memories, network interfaces, but it's not the user data. All the user data live either in Fabric controller in the shape of NVMe disks or that rotating spindle if you need the archive or something of that kind. The sense is that we have PCI Express that we need anyway, and on top of it we need to do something. Nobody is against. You can install the RDMA adapter inside the Fabric controller. And then we get at one adapter the network of InfiniBand without the wires within itself. That's also the option. One more question. Thank you. Thanks for the previous answer. And this is the other question. If I got you right, and the case with RDMA, only the target processor is unloaded. The source node also uses the processor when sending the data. So it doesn't unload the processor that much, not like everybody thinks. Doesn't it happen that due to encapsulation of Uniband in the Ethernet, the productivity isn't that high? It depends on what you compare with. No one is using. I don't know who would use the Ethernet directly as a transport protocol for certain things. If you have the Ethernet, then you have the IP, TCP, or UDP, and the same encapsulation, but of a different kind. Hence, if you have a device that can offload all the parsing, which enable to offload plus to unload one of the sites, that's not bad. Otherwise, two sides are loaded. In this case, only one. I see. I'd like to specify whether you did serious load tests and how much more efficient is the option. Frankly speaking, no, we didn't do that. We didn't get to that stage. We didn't get to CAP because RDMA seemed good enough. We had the realization of what we do at RDMA on top of TCP IP. It was faster, but I don't have the figures to tell because it was done on VMs. It was an experiment, not what I can show on slides. So in theory, it's better. In theory, yes, they say it's better. You may trust what they say in the internet. So if you do test, please write an article about it. We are interested.
No. Oh, yeah, we have a comment. У нас есть комментарий, как я чувствую.
I feel we have a comment. But don't make it a discussion. You can only ask questions. Oops. It's a question. I didn't quite get what was the problem with the previous question. You say you don't understand why NAG is not sent in certain situations of certain errors. Did you try to ask? My experience of socializing with Linux computing, you are not. They respond you. They explain what the problem is. I agree that it should be done, but so far we didn't get to that stage. We have a plan to ask about it. We just fixed it for ourselves. We feel happy, and it's not productive from the point of view of community, but we're happy with what we have. It requires time, you know. So if we don't have any more questions, let us thank the speaker one more time.